Hello, everybody, and welcome back to the 2022 One Sustainability Conference. We have a super excited session happening right now with Matteo Pietrobelli, the Chief Engineer of Oceanics, and Flora Bao, the Project Manager at BIG. You guys take it away.
Thank you very much, Stelios. Hello, as Stelios mentioned, I'm Flora Bao, Senior Project Manager at BIG, or BRK Ingalls Group. And today I have the pleasure of introducing Matteo Pietrobelli, whom I've worked with closely this past year. Matteo is the Chief Engineer at Oceanics with a background in civil and bridge engineering and expertise in smart cities and systems engineering. He is deeply interested in integrating all aspects of engineering into our built environment. In the face of climate change, he is here today to share with us all the intricacies of designing and building floating infrastructures that can support an array of urban live, work, play programs, as well as programs needed for industrial and infrastructural use in the future. So here is Matteo Pietrobelli on floating infrastructures, climate and blue technologies for sustainable, resilient, scalable, and inclusive habitats. Matteo?
Thank you, Flora, and thank you, Stelios, for having us. Very much appreciated. So I guess I'll start in explaining our vision. So Oceanics has been developing in Busan in South Korea something that is truly unique. We started asking ourselves what is going to happen by 2050, and the problem is that we're going to be 10 billion of people on our planet, and this will increase the demand of buildings, and of course the demand of energy, and of course the footprint from a carbon perspective. And the idea is that an increase of that size is equivalent to adding London to the planet every 2 months for the next 35 years. And then we all are aware of how the construction industry is heavy on the carbon emission, more than 50% of the overall built environment. And if we want to add a cherry on the cake, unfortunately, by 2050 as well, 90% of the world's largest city will be actually exposed to the rising seas. This can be everywhere from Miami in the Venetian Causeway or Venice in Italy. It's really spread out around the globe, and we can see it as a really tangible threat. And so the question is, how do we approach living on water and how we welcome it? And by doing that, we really started to look into experiencing and understanding the global shift towards a more sustainable design. And by doing that, we looked into the existing sustainable initiatives that are around the world. And by raising our bar in response to the 2030 agenda of the Sustainable Development for the United Nations, we really used those sustainable development goals from a built environment perspective to reach an overall completely sustainable built system that is sustainable from energy, from water, from waste, food, and mobility, and habitat regeneration perspective. And by doing that, we also been learning from different communities around the world and from the people and how people are actually interacting with each other. And by nature, of course, the idea is to use a biophilic design. And in addition to that, by defining the project and by defining the system and our solution, in a scalable way, we're really accomplishing something that is a sustainable, flood-proof solution that is adaptive, is scalable, and easily reconfigurable for all of the evolving needs. And in addition to that, it's a design that flows through energy, water, food, waste systems, in order to basically represent a sort of a footprint of a maritime metropolis. And so the question is, how do we do that? And we started with defining a modular approach in assembling our floating platform. And by a modular approach, we also were able to define a buoyant, resilient, and stable floating platform that can represent the foundation of our built environment. And so by being able to segment our hull into different spaces and by integrating the different systems within the hull, we were able, with each one of the kit of parts, completely in a closed loop system and in a way to recreate a specific ecosystem, vertically integrated within the different programs, and of course within the different building system and platform systems, to really define engaging structure. And in addition to that, we also define the performative pedals, which are the regenerative, the social, and the mobility component of the structure and of the system. And for the specific project of Busan, we define the regenerative pedals, and that takes into consideration aquaponic and hydroponic treatment systems for plants and also for garden perspectives. We had the communal and regenerative pedals for social engagement, as well as mobility pedals for the transportation, or in general for the more multimodal hub perspective. And so by doing that, we also defined the construction to be done with sustainable materials and locally and eco-friendly material that can be sourced on the area where the structure will be built. And the idea is to also define that from a modular perspective. So the building, and so therefore the top side and the hull side will actually be completely designed and built in a modular way, in order to basically really be a low footprint system that is driven by green energy and that can achieve a completely self-sustainable floating city. In addition, we also defined the opportunity to add another layer, which is the smart layer, the data layer, in order to transform the city into what is a futuristic and smart technology-driven system. And what is very important for us is also to detach ourselves completely from the legacy network and the legacy grid lines, let's say from an energy perspective, from a water perspective, from a waste perspective. Really completely detach ourselves from any legacy network in order to be completely decentralized, still representing as a plug-in to coastal cities, but without burdening the already overburdened legacy system. And in addition to that, of course, our platform is able to accommodate any type of building typologies. And in addition to that, those building typologies can actually be any type of programs, from spiritual centers to athletic hub to health centers. And by using our urban design guidelines in terms of perimeter circulation, in terms of massing, in terms of footprint and height, we're really able to create a vibrant public realm. And so this is just an example of a cross-section of how the system is cut through, where we have a mobility system, the food production, the hydroponic systems, and really the way the programs are distributed for a really a generic, let's say, cross-section of our system. And that goes in the way we actually integrated them together in order to basically achieve complete redundancy, but also complete sustainability. And to have a better understanding and a clear idea of how this might look like, this is how the experiential section of the platform will actually look like. And so for the specific project of Busan, we really focus on three major programs that were very important for the city, very important for the different stakeholders involved, and of course for the United Nations as well. And we've really focused on research, living, and lodging. So the idea is to have three platforms that represents a plug-in neighborhood on the north port of Busan, where we have overall amount of 12,000 occupants between researchers, between residents, guests in the lodging platform, and of course visitors as well. And we thought about also how to maintain circularity and the circulation from a mobility perspective. And so we designed micromobility within the different platforms and between the platforms. But in addition to that, we also envision a way to connect and maintain mobility between the platforms and the mainland. And so in addition to the micromobility system, we also define the macro mobility systems in order to basically allow the connection and a sustainable connection with the existing transportation systems that are inland in the city of Busan. And so, in addition, what was important for us was to really learn from Busan city, from the citizens, and really from the urban fabric of the city. And in addition to that, also from the public realm of Busan, with their alleys and with its alleys and its characteristics. And by doing that, we basically designed the first prototype to represent a plugin, an extension of the city on the water. And we've done this by really defining the prefabricated high-performance building facade to represent, to really be able to transfer a similar perception of the city of Busan as well, while also being completely sustainable and eco-friendly. And so this is an example of our roof plan. And this is a renderized view of the same plan and the prototype. And so Busan right now is going through a huge redevelopment program, especially in the North Port. This is divided in two phases. This is how it's going to look like once the old development program is finished. And our platform will be located in the North Port on the side of what is called phase one. And really, what we're going to do right now is we're going to go into the more detail about the different platforms and how they're organized and how driven from a design perspective. From the research point of view, we really wanted to integrate different programs, from makerspaces to co-working places to marine research hubs to aeroponic systems, in order to basically be not only integrated from that perspective in terms of technology innovation, but also in order to guarantee a really seamless experience for the researchers and to really represents the forefront of technology from a climate tech and blue tech perspective. And of course, this is just an example of how this can play, not just from a infrastructure point of view, but also from a smart layer point of view. From a living perspective, what we really cared was making sure that the residents will experience a very safe neighborhood. And so we focus, of course, on the housing, but also on the community center, on daycare for supporting parents, and on the food and the produce that can really come from the same area where they are produced. And in order to do that, we define smart systems for home security. We, of course, integrated with the aeroponic and hydroponic systems and domotic systems to really guarantee a smoother transition and a smoother experience. And this is just an example of the view of the platform from the outside. For the lodging, what we've been doing and we've been working on is really designing an eco lodge. A lodge that is completely sustainable and is on the forefront of sustainability from a system perspective and from, of course, a program perspective and an architectural integration perspective as well. And so what we envision is an integration between a gathering space, of course, a lodging, a hotel space, a health hub, and different pavilions from a climate change perspective and also from a habitat regeneration perspective, which is very important for us as well. And as you can see from the way we integrated, we also wanted to guarantee smoother experience for any type of visitors in order to basically avoid any type of discomfort. And in order to do that, we develop smart kitchen systems integrated with the auto check-in systems and with the security systems as well. So this is really an example of how the platforms and the different alley will look like during the day, it will look like in the night, and how the perception of the residents in relation to, of course, the existing city of Busan will be perceived. And that's an example of the aerial view from the night, from the water side. And the idea really is to start with our prototype of the 3 platforms and eventually expand into a bigger neighborhood. And eventually, by learning about the integration of our technology from a sustainable perspective, also being able to apply them on land as well. And at the same time, this is a prototype for Busan. Busan has been the first mover, let's say, and at the forefront of applying this new system from a climate mitigation perspective and from a sustainable perspective. But we're really trying to apply this in different geographies, such as in the Middle East or in Africa or in East Asia, as well as in the Northern Europe area. And the idea is really to apply it also in different cities and in different countries. They're experiencing the risk of overpopulation, of seawater level rising, and the risk, of course, of becoming climate refugees. And so we've been envisioning this in the Maldives, in Lagos, in Wellington, in Monaco, in Dubai, as well as in Rio de Janeiro or in Miami, and as well as here in New York City. Thank you very much.
Thank you very much, Matteo. So this is the Oceanics Busan project that has been presented, and I guess, while there's no questions right now, I mean, I know this project pretty well as well, and I think that, what we want to kind of convey is that the platforms that we're designing they're just kind of a module that can actually support any sort of program that we decide to place on it. And the size and scale of these modules maybe is something that we could talk a little bit about, because I think that there's a lot of discussions about floating cities in general. And I think that some of them are very large scale, maybe similar to this one. Other ones are, much smaller and very defined programs. And so I think the intent for this floating city or this prototype is to convey that we can use the water right now as kind of a real estate to be able to expand upon the land and to allow us to continue living on Earth with additional population in a way that is very seamless with the way that we live on land. But I think with only a few restrictions in terms of how things are built infrastructurally and physically in water would have different set of rules and different set of building systems than building methodologies rather than on land. So could you explain a little bit more about just the size and scale and feasibility of building these platforms in water?
No, absolutely. So, I mean, the scale of this platform is 1.6 hectares, to be specific. It's a large scale. It represents, from a size perspective, a New York City block. And the reason why the size is being defined as such is not just because we wanted to go with a size of a New York City block, but because the analyses were driven by comfort and safety. The most important thing, as well as, even though we are absolutely in protected waters and protected harbors where the wave heights is, of course, mitigated by the presence of already seawalls or safety infrastructures defined for the safety of maritime operations, but in general for the safety of the NATANs. They are actually in the port, so ships or any type of commercial operation from that perspective. What was important is to guarantee comfort. And it requires a specific analysis in order to do that, from hydrodynamic to actually hydroelastic analysis that really allows us to understand what is the perception of the dynamic perception of vibration and of accelerations that the human body will experience horizontally and vertically, in order to really do not even feel the presence of the water, even in situations where we might end up having wave heights of 3 to 5 meters. And so, of course, that would not happen because, thankfully, by design, we've been trying to keep it down to 1.5 to 2 meters high. But even with those type of wave heights, we can guarantee complete comfort. And this is not just done by based on simple analysis, but we compared it with different guidelines from around the world, not just in the United States, but guidelines that come from the different navies around the world, and also from different classification companies and societies around the world.
Mm-hmm. And yes, I think that many people may be, wondering, living on water, it's, people usually think about more small scale boats, ships, but then when it comes to, if you're on a large scale carnival, ship, that you really don't feel anything when you're on those ships. So, I mean, in a way, this is kind of similar, where we're trying to create something that will continue to be in the water and and the more that we connect to each other for these modules, the more that these floating cities and platforms will be stable.
Yeah, that's correct. And in addition to that, there is a huge trend right now in of course trying to tackle the seawater level rising, right? And there are, of course, different options and there are different approaches. And one of them, for example, is land reclamation. But land reclamation is incredibly expensive. It's been, of course, tested, and we have a lot of examples around the world. But in addition to be expensive, is incredibly unsustainable. It requires to dredge sand from around the world. It requires to replace that sand in another location, destroying completely ecosystems, and also requires a lot of time, you know, for the sand to settle, right, and being able to actually build on top of it. So.
Yes. And we have a question from Nicholas Barbakis, whose question actually plugs right into this. And his question is, how much more expensive would it be to build on the water, and how safe would it be? So I think we kind of touched upon it a little bit, but I think that your description just now about, what is the cost otherwise, right? So maybe we could maybe talk a little bit about the expense of just building it. And maybe you can also expand on, what is the alternative?
Yeah, no, absolutely. I mean, that's actually a very good question. In terms of cost, we've been doing our analysis, and we also been approaching the design from a modular perspective, exactly because of the importance of guaranteeing, let's say, replicability. And of course, modularity allows to do that. And it allows also to design it once and then be able to always build it again in multiple locations and in different in different geographies. In terms of cost, our analysis shows that is not different from, let's say, a mid-rise construction cost, and it allows actually to then guaranteeing from a rental perspective, because of the programs and the way it's been designed, to really have an integrated population of residents that goes from, of course, high-end on the middle income to actually affordable and lower income. We'll be following the United Nations regulations in relation to percentage of affordable housing that goes into the residential component, and we really allocated certain percentages by United Nations regulations that can basically, they've been allocated from a affordable housing perspective. So it's no different from any coastal city at all.
Yes, and I think that it's a good point to make that actually these platforms that Oceanics is working on. Oceanics is a corporation, and you guys are looking to make these platforms, and they are not meant to be just a city or state funded type of project. This is meant for something similar to any sort of development where
Absolutely.
there is ROIs, where you do have a sustainable, not just a sustainable system of living, but also a sustainable economic system for just being on the platforms.
Absolutely, absolutely. And it's important for us, as you mentioned, sustainability is a key, right? And therefore, in order to be sustainable, you have to also be a sustainable business, right?
Yes,
and so,
sustainable, social, and economic, and ecological.
Absolutely.
Yes.
Absolutely.
And also Ronnie Peters has another question that may be a little bit different, but maybe it's something interesting that we can expand upon, is can the platforms be moved to different locations?
Oh, I'm glad actually he asked this question. So this is very interesting because, from a perspective of the built environment, the design has always been done to, build it and then leave it there. Then if in 75 years, we'll see what happens, right? Our approach was very much done from a system engineering perspective. And that when I say that is because we really integrated a life cycle into the design. So from an operational, from a functional, and also from a performance requirements perspective, we also considered the maintainability, the operability, and of course the let's say more of the disposal of the system. So once it reaches the lifetime of the top side, let's say of the building side, in 50 to 70 years, based on the life expectancy that we design for, we can of course reuse the platform for other purposes. And because we're also adopting a concrete, which is a biophilic marine concrete, which is being used in offshore applications, the idea is really to not only have the concrete to become a carbon sink from an environmental perspective, but also to last longer, to require less maintenance, and also to be able to, in case of some maintenance will be needed, to be repaired or to be maintained easily and in a cheaper way, so to last way longer and be able to be used for different purposes.
And the 75 years is specific to this project. It's not, right? This is something that maybe if we were to do in Busan, these are some of the, number of years or the life cycle of the platforms.
Yeah, no, 75 years also from it's a code regulation, right?
Mm-hmm.
We didn't made it up. It's a code regulation, and that's a code for the building side.
Mm-hmm.
I want to be clear that from a platform side, we actually designed the platform for a return period of in terms of loads, and not really in terms of expectancy of life of 250 years.
Mm-hmm.
So the idea is.
Yeah, so I mean, these platforms can certainly be moved as they are floating, right?
Yes,
So
yes.
I think that, but I think, we can move them around in the water in that bay. Can it be moved all the way across the globe? I mean, I think it's feasible, but I think that we should understand that anything that we design that is sustainable is also contextual, right? So when we design for the city of Busan, not only is it sustainable for the climate in Busan, but it's also sustainable for the culture of Busan. But it would be interesting where, one day when we have a World's Fair somewhere, you just pull these platforms from all over the globe into one central location and, see how each other live on these platforms and what the differences are. But
Yeah.
I think they're meant to be in a certain place because of the context.
It's true, but the beauty is that because we are dealing with plug and play systems that are completely detached from the grid, you're actually able to use in different locations. Of course, solar exposure, rain quantity for harvesting, and the quality of the water is of course locally driven, right? And so all of these environmental information and environmental characteristics are locally driven. So they might require some tweaking, in order to basically be applied somewhere else. But yeah, I totally agree.
And to wrap it up, it's really when we talk about the building side or the whole side or the base of the platform is something that can be reused over 250 years, and you can plug and play whatever you want on there.
Absolutely.
And the top, of the building, which is less time in terms of life cycle, can also be replaced, and the program can be changed based on where these things are.
Absolutely.